Now, what if there are decimals? How can we deal with that instead? And it's kind of the same, I mean, it really is exactly the same thing I said about fractions in the previous video, is that you could still deal with an equation. Let's say we're going to try to solve this one by just working on it as normal and ignoring the decimals and just doing decimal math. So let's go ahead and try that. So let's say we're going to deal with, I don't know, this one right here. So since I have parentheses, I could multiply that out. That would leave me with 3x minus, and 3 times 2.1 would be 6.3. And that would be equal to 2x minus 6.9. And now I want to put all the variable terms on one side. So I could subtract 2x from the right-hand side to the left-hand side, which would leave me with just x. And I can add 6.3 to the right-hand side to put all the numbers on the other side, which would leave me with negative 6.9 plus 6.3 is going to be negative 0.6. But in the same way, if decimals are, if you struggle a little bit with doing basic decimal math, I mean, of course, you could do that with your calculator as well. Negative, it's a little too big, I can't click my negative sign. Negative 6.9 plus 6.3 would leave me with negative 0.6. You basically could just do the math, do the decimal math with your calculator, no problem. But another strategy would be how do I get rid of decimals in the same way that I get rid of fractions? And really, it's always by multiplying by a power of 10. And this is because really every decimal is technically a fraction. It's just an alternative way of doing fractions, like any terminating decimal. Like for example, 6.3 is the same as 6 3/10. So the way to get rid of a decimal is to multiply by the denominator 10. And that's kind of the essence of the trick. Or if you have a decimal with 2 places, you multiply by 100 because you're moving into the hundredths place, and so on. I don't know if you've ever really thought about that before. But that's something that, we learn these tricks a lot, but don't necessarily think about why they're true. But if we were to re-look at this equation, I just wanted to illustrate the multiplying trick and why it makes sense. But here, if I multiply by 10, again, that's kind of like what the denominator is. Multiply the left-hand side by 10 and multiply the right-hand side by 10 as well. And again, I would choose 10 because I have one decimal place. If you had 2, you would choose 100, 3, 1,000, and so on. Add a 0, we'll technically multiply by 10 for each decimal, each number beyond the decimal point. And we can see what happens. Well, 10 times 3 would be 30x. 10 times 6.3 would just make 63 because there's the moving decimal point rule, which is when you multiply a decimal number by a power of 10, you move the decimal that many spaces. And again, that's just because really this is 6 3/10 or 63/10, and if I do 63/10 times 10, I'm left with 63. And then on the right hand side, 2 times 10 would be 20 times x, and 6.9 times 10 again for the same reason would be 69. And the point of this trick, which is multiplying by 10 to both sides to get rid of the decimal, is exactly that. Now I have an equation without decimals, and then I can go about solving them having no decimal numbers. And I think you can probably agree in this case, it's probably easier just to solve with the decimals, but depending on the numbers, sometimes removing the decimals would be nice. I usually wouldn't recommend doing this, but whatever. And then I could subtract 20x because again, I want to get all the variable terms on one side and add 63 because I want to then put the numbers on the other side. That would leave me with 10x is equal to negative 6. And then if I were to divide both sides by 10, I could cancel out the coefficient, would leave me with negative 6/10, which is equal to negative 0.6, because remember that's 6/10. So anyways, we get the same answer, but that's, what we call the trick for getting rid of decimals, multiplying by powers of 10.